This is session BOV 1193, Microservices and Kubernetes, an introduction for business leaders. So thank you for joining me in this session. My name is Brian Petch. I'm a sales engineer with SUSE in the UK and Ireland. And for the next sort of half an hour or so, we're going to have a look at a few topics. We're going to look at business and technology, and particularly the relationship between them. We're going to look at application design. Don't worry, this is not a technical session. This is very much an overview, an introduction, and meant to help to understand the next couple of topics, which are containers and how they plug into application design and what they are, and then Kubernetes and how that plays in this picture as well. At the end, we'll loop back and look at how SUSE can actually help support you in your business and with the deployment of these technologies. So let's start with business and technology, and again, the kind of link between them. These terms, containers, microservices, Kubernetes, we might hear these in meetings or around the water cooler. But if you don't work in these worlds, if you don't use this stuff all the time, you may not have a clue. We can't learn things by accident. So, what are they all about? What's the point of these particular technologies? And the bottom line is basically business flexibility. So, yes, they're great, technologies in their own right, but their goal ultimately is to deliver flexibility to the business, to allow you to adapt to change, and to be able to adjust to changing business conditions, whether it be from competition or external forces. So let's go back and just look at business and technology generally. I mean, why do businesses use technology at all? What's the point? And the answer, of course, is to support or deliver the processes that the business needs to actually operate. In the 21st century, IT processes is intimately linked with business process. So technology is required to actually operate the functions of the business. And it's interesting to look at a few different business types just to see and compare and contrast the load on those businesses and how that can be addressed. Take, for example, I want to just standardize or simplify my accounts processing. Maybe you're a JCB or a Office Depot. You've got lots of locations around the country or the world, and you just need to standardize your accounting processing. That's one particular use case. Another one might be to say, I want to advertise and then sell my products on the internet. So someone like a Walmart, for example, might do that kind of business. And then the third kind, of course, is those businesses that deliver a service. So people like Uber or Netflix, for example, where the service that they provide is the business. That's what they are. That's how their business works. And just to look at the load that those particular styles of organization face. If you consider the accounts processing piece, the demands that the IT infrastructure faces there is it's all internal for a start. So it all comes from internal sources. It may be in response to things like financial accounting requirements or regulatory requirements. But it's all generally pretty predictable and well known. We know when the end of the quarter is if we need to collate sales data, or we know when the end of the financial year is to build annual accounts, those kinds of things. So predictable workload. If you're advertising and selling on the internet, the demand is all external. And again, after sort of a setup period, you'll probably reach a steady state where the actual demand or on the service, IT service, is relatively steady. There's probably some seasonal peaks that you have to deal with. So, things like holidays, for example, Christmas and Thanksgiving. Those kinds of things can drive higher demand on the business and thus the IT infrastructure. But again, those kinds of things are, pretty predictable and well understood. Even things like, a sales exercise, for example, you would be under control of that. So again, fairly predictable. If you're one of these, born in the cloud kinds of businesses, so the Ubers and the Netflix kind of organizations, then the demand is all external. So it all comes from the outside, and it can be highly variable. So take Netflix as an example. Let's say they, release a new TV show on their platform. Perhaps that TV show, just happens to, catch the imagination of the public and becomes very, very popular overnight. That can drive a huge demand on their IT systems to deliver that, increased level of service. So more and more people jumping on very quickly. And of course, they want to retain quality of service as well. So it's a real challenge to manage those kinds of workloads. The thing that's common, of course, across all of these business types and indeed IT types is that it's actually the applications that deliver the functions that the business require. So yes, we all need servers and infrastructure and that kind of thing, but it's actually the applications that deliver what the business actually needs to function. If we look at businesses in a more general case, there's probably two categories. Maybe more, I suppose. But if you break them down into sort of newer companies, so fairly recently formed, they've generally got a fairly free hand to decide, what their infrastructure and their applications will look like. They've got a green field, so to speak, to deploy what they need to do in order to deliver the requirements of the business. So that's fairly straightforward for them. Older companies have a legacy of their previous years. Legacy is probably a fairly negative term, so I prefer to think of it as just history. And of course, it's a good thing because that's what the business is built on. It's good that a business has history and has been around for some time. It gives it some stability. But it does mean that that business has some baggage to carry. It's got existing processes and existing infrastructures in place. So it does make things more difficult to change. Consider a tugboat, for example. It's fairly small, it's fairly agile, it can move around fairly quickly, but as you get to bigger and bigger boats, they're harder to actually steer and to turn in response to any particular event. And of course, many organizations have figured out that they really need to be more adaptable in order to survive the variety of pressures that they face in the 21st century. It's interesting to consider natural selection for a second. This is the term coined by Charles Darwin, of course, back in 1859, and has often been misquoted as survival of the fittest or survival of the strongest. In fact, Darwin himself said that at one point and then corrected himself. And in his book back in 1859, he talked about natural selection as the principle by which each slight variation of a trait, if useful, is preserved. Another way to express that might be to say that the species that survive are actually those who are able to adapt to the environment around them, rather than the fittest or the strongest species. So a good example probably is the dinosaurs. They ruled the earth for several 100 million years, very dominant. But when the meteorite hit the earth and changed the atmosphere, they weren't able to adapt quickly enough and so died out. Whereas other species did manage to adapt and continue to this day, or at least onwards. So moving from prehistoric times to today, there's a long list of organizations who've really failed to adjust to changing market conditions and have suffered either very heavily or even to their demise as a consequence. Take Blockbuster as an example. They really failed to recognize the rise of Netflix and the streaming services, so they ended up going bankrupt. BlackBerry were very strong in the corporate marketplace, but almost neglected the consumer space, and so Apple were all it gave them the window to take over the consumer marketplace, which then dripped into the corporate marketplace, leading to the demise of BlackBerry. Another interesting one is actually the New York taxi cabs. Again, Uber's been around for a few years now, but even as early as October 2017, Uber had actually recorded more trips in Uber cabs than the New York Taxi Company in its yellow cabs. So that's really quite a significant rise to fame. And those journeys that have gone to Uber are lost business for the New York taxi companies, probably never to return. Excuse me. So let's now look at application design and how that plugs into this discussion. We've already said that businesses use technology for their operations and to underpin the processes that they need to operate. That technology needs to be adaptable in order to accommodate change, as we've discussed. And it actually turns out that containers and Kubernetes and microservices can actually provide that adaptability for applications. So what's a microservice? Well, before we look at microservices, let's look at traditional applications first. So this is a kind of an example case of, again, think of it as a taxi cab hiring application. So we've got the kinds of functions that you might think of, so billing and trip management and driver management, those kinds of things. And each of these capabilities are functions within one application. So you've got one big lump of program code, often referred to as a monolith. That probably sounds a little derogatory, but it's often the term that's used. So each of these little functions, so payments or trip management, they are functions within one big application. And because it's all part of one big application, it means that if you change one piece of it, you have to test the whole. So it kind of makes it very difficult to implement change with applications that have this structure. Typically, you've got to rerun regression testing or performance testing or all kinds of things like that in order to make sure you haven't introduced a problem somewhere else. So because that it makes it difficult to change, it's difficult to add new functionality and again to add new capabilities. And because you have to plan everything up front and then test things very, very carefully, you find that with the traditional applications, the release cycle of the application can be quite long. So anywhere between 6 and even 18 months between releases of the application. So that's quite a long time frame in the business context in terms of making a change to a particular application. There is another way, of course, and this is the microservice-based applications. This diagram looks pretty messy compared to the previous one, but it's actually very similar. So all we've done, excuse me, all we've done is to take the individual functions that are part of the big application and put them in their own little box. So that little box is a microservice. So it's just a single function, a single piece of capability in its own little service. And it's presented as a service to the network via an API or application programming interface. That provides some abstraction, but the individual functions communicate with each other over the network. The value of this kind of approach is that because the functions have been separated into their own little service, you can actually change any given function without actually impacting the rest of the whole application. So let's say, for example, you wanted to add a new credit card provider into your billing function. You just make that amendment, make that change into the billing microservice, and off you go. Again, it doesn't make any difference to any of the other functions in the service. And as a consequence, this ability to change the functions more easily means that you can do it more rapidly. So you can actually, increase your release cycle for changes to the application. And typically, release cycles for microservice-based applications are much, much shorter than for traditional apps. So we're talking about days or maybe even hours between releases. Some organizations use this capability already and are making several changes to their application throughout the day. The other thing to note is the actual small services, the individual functions, do lend themselves to being deployed as containers. So that leads us into what's a container. And again, before we look at containers, we'll look at traditional deployments to compare. So traditional deployments are usually on a sort of a virtualized infrastructure. So we'll have a server that runs a host operating system on top of which you run a hypervisor. That provides the virtual machine capability or VM capability. So you build multiple virtual machines, each of which requires its own guest operating system. And then on top of the guest operating system, you can run the colored blob here, which is our application that we want to run. And you can see straight away that there's a level of redundancy here almost. We've got several VMs, each of which is doing hardware abstraction. We've got several guest OSs. That could be duplication of storage, and all of it requires processing and memory. So levels of inefficiency there, although virtualization was introduced really to deal with the issue of hardware utilization and it being too low. So you could then stack applications inside a single system. So with a virtualized deployment, we've typically got, say, a host OS, which is Linux or Windows. The hypervisor layer is most commonly VMware, sometimes Hyper-V or KVM if you're on Linux. And then within your virtual machines, your guest operating system is most commonly Linux or Windows. Compare that with a containerized deployment. So we still have a server. You always need a server to run things on. You always need processing and storage and memory and stuff. But we have a single OS kernel, again at the bottom. But on top of that, we run a container runtime. And that's kind of like an abstraction layer that allows us to run the multicolored blobs on the right-hand side are containers. So the container is literally a sort of just the application code of the application you want to run and any dependencies that it might have. So things like libraries. So that gets packaged up into a container. And then that can then execute on top of the container runtime and then subsequently on top of the server. And because we're not doing hardware abstraction with the hypervisor and we're not doing operating system separation with the guest OS, they are much more lightweight. Excuse me. So containers are much more lightweight than virtual machines. So you can run many more of them on a server, for example. That's not really the main objective. But one of the other consequences is it can take a couple of minutes to spin up a virtual machine, but you can start a container in a number of seconds because you haven't got to boot an operating system, that kind of stuff. So ultimately, containers are much more efficient than virtual machines. Again, from a container deployment, the operating system is typically Linux. Containers started out on Linux. And then the container runtime is typically Docker. You've probably heard of that. There are other container runtimes, and they are starting to become more prominent now. But most commonly, it's Docker. So we've got containers, and they're lightweight and they're fast and they're really efficient, and that's great, isn't it? But there's always a catch, of course. It's never just straightforward. And that catch is that if you think about that microservice diagram that we saw earlier, we've got one application there, and yet there were probably a dozen boxes on that diagram. So that would be a dozen containers potentially. So those containers need to be organized and orchestrated. So that was just one application. Can you imagine if you've got lots of applications? You end up with lots of containers, and you need to manage all of that and make sure everything's behaving the way it should. So if you're deploying containers at scale, you have to worry about these kinds of factors. So making sure things are running where they should be, making sure you've got enough containers running for your particular service. Maybe you've got a web server, for example, and you run 3 copies of the web server. But what happens if the workload increases? You need to spin more up. You want to be able to scale it. Self-healing, again, imagine the case where we're running our taxi application and the billing container goes down. You need to be able to restart that one, otherwise your service is going to be quite badly hit. And of course, you've got to deal with issues like making those updates that I've spoken about. You need to be able to roll out new versions of the code and potentially roll back to an earlier version if you've tried something new and it doesn't work. This leads us neatly on to Kubernetes. Kubernetes is actually a Greek word. It means pilot. So think of it as telling all the containers where they're headed and what to do. So Kubernetes was originally created at Google. They wrote this system to manage the containers that they were running inside their data centers. But thankfully, they've open sourced that and donated it to the Cloud Native Computing Foundation, or CNCF. And really, Kubernetes is fundamentally designed to coordinate and orchestrate container workloads. So grouping them into logical sets. For example, all the containers that comprise an application, dealing with scaling and issues like that. One point is that Kubernetes is often, when it's written, it's often abbreviated to K8S. Still pronounced Kubernetes, but people don't like to type that long word sometimes, so we get shortened to K8S. That's what that means. And again, just to look at some of those details of what Kubernetes deals with. I mentioned scaling before, so the notion of having a web server farm that's running 3 containers and your workload goes up. Kubernetes can actually spin up another couple of instances for you in order to maintain service levels. Things like storage orchestration. By default, containers are very ephemeral. They come and they go, and there's nothing to know they've ever been there. There's no notion of persistent storage by default. So Kubernetes can help managing persistent storage when that's required. Service discovery and load balancing. So again, typically you deploy your Kubernetes cluster across a variety of machines. So you need to balance things across those machines. And then from the service discovery perspective, containers kind of operate in isolation. They don't know about each other. So you kind of need to provide a map that allows you to connect to the service that you want to deliver out to the outside world. And again, this is something that Kubernetes can handle. And lastly, things like secret and configuration management is something that it also deals with. So dealing with things like trust relationships and passwords and those kinds of issues between containers and services. So I've mentioned that Kubernetes was originally conceived and built by Google. It's nice that it's now with the Cloud Native Computing Foundation and open sourced. SUSE does love open source. But it's also seen incredibly rapid adoption in the community. So it's very, very quickly become the de facto tool for the orchestration of container workloads. And this rapid adoption has led people to use it in stranger and stranger use cases. So again, the original design was to manage containers within a data center, but we're finding that people are using this model to deploy containers and to manage applications in sort of wildly different circumstances. So sometimes they're doing it in the public cloud, sometimes they're doing it at branch locations, and even out at the edge. We've got customers who are running Kubernetes environments out in wind farms, for example, or with telecom cell towers, things like that. So because Kubernetes has seen this proliferation, and we're running Kubernetes clusters in a variety of locations, often several times, different clusters for different use cases. We're now actually at the point where we need a tool to manage Kubernetes. So although Kubernetes is our management tool for containers, we're now at the point where we need to manage Kubernetes itself. And to be fair, it's at its rawest, it's not the easiest of tools to use. It's very command line driven. It's very deeply technical. So not the easiest thing to use out of the box. But in terms of managing, multiple Kubernetes clusters, this is what SUSE Rancher provides. So you may be aware, SUSE bought Rancher Labs back in 2020, and that provides the extension of our portfolio up into the application space to help manage, containerized workloads. Looking at the portfolio, we still have our core competencies, which is around, enterprise Linux. SUSE has been doing that for 30 years now. So we still have all of that, and it continues to develop, including into the containerized space with SLE Micro. So SLE Micro, or SUSE Linux Enterprise Micro, is a lightweight, streamlined version of Linux targeted specifically at running container workloads. So we're kind of covering that end of the spectrum as well. Excuse me. And then Rancher sits on top of that, up at the application layer, managing Kubernetes and containers and the variety of other capabilities that are required when you start to deploy these containerized workloads. And again, some of those details are for other sessions, let's say. I would also mention NewVector. That was a very recent acquisition by SUSE. And NewVector provides application level security. So again, when you've got containers talking to each other over the network, NewVector actually provides security management actually at the application layer. So the level 7 in the OSI stack. And of course, all of this actually runs across all of the kind of deployment options that you could think of. So whether that's a developer laptop in your on-premises data center, in the public cloud from various providers, or in branch locations, or even out at the edge, as we've discussed. So to summarize what we've covered today, containers allow businesses to build applications that basically can change much more easily and thus quickly in order to meet changing needs of the business. That adaptability is vital in terms of changing business circumstances. And those kind of circumstances that you might run into are, some examples might be Brexit or the challenges from COVID, or maybe even from a new competitor that's entered your particular marketplace. So containerized applications are great, but they do require orchestration and organization. And Kubernetes is the de facto tool to do that management. And finally, SUSE Rancher allows businesses to manage, secure, monitor, delete anything you'd like. It allows you to do all of these for Kubernetes clusters, regardless of where they're deployed, whether that be on bare metal, in virtual machines, or in the public cloud, for example. So with that, I'll say thank you for listening. Thanks for your attention. I hope you've found the session useful to get a grip with some of these technologies. and I hope you enjoy the rest of your SUSECON. Thank you.